Welcome back to the second segment on overview of site remediation or cleanup. In the first segment, we talked about why one would want to remediate a site. We also spoke about the conceptual site model and talked about the effective targeting of mass and how mass sometimes can diffuse into lower permeability segments. Today we're going to be speaking about the remediation objectives, and in the following segment we'll be speaking about technology options. Remediation objectives or goals are those clear statements of what we want to achieve when we set out to clean up a site. Here's a quote from an NRC document that specifically outlines the understanding of remediation objectives. The success of source remediation requires the specification of remedial objectives with clarity and precision. This includes knowing the full range of site remedial objectives, their relative priorities, and how they are defined operationally as specific metrics. So clearly the words I've underlined here are clarity and precision and specific metrics. So the objectives have to be specified so that they're clear and precise. And then we need some way to actually measure, in fact, that they have been met. The statement of remedial site objectives are vast and broad. There are multiple stakeholders involved, including the site owner, the consulting firm that's been hired, the regulatory agencies who are responsible to ensure that the site becomes clean. The local neighbors are very important as well because they have a very real need to see the site in fact cleaned up. They all may have different objectives on what they want. Likely the client would like to clean it up with less funds, while the neighbors want the site pristine, brought back to perhaps cleaner than background. The regulators want to ensure that the intent of the law is held up. They all use similar language to describe different objectives. They want the site clean, but from a client's perspective or from a site owner's perspective, that's not the same as from a regulatory perspective or from somebody who lives close by the site. Quite often the data presented on the remedial process are somewhat irrelevant to the stated objectives. For example, if the stated objective of a site was to reduce mass, and the data reported are quarterly reports on groundwater concentrated at a nearby well, although those are related to each other, the data are not presenting a clear understanding of the stated objective to reduce mass. And quite often, objectives are stated so imprecisely that they are impossible to assess. There are short-term, long-term, and sort of end-game objectives. Short-term would be to reduce the mobility and reduce the immediate risk. Perhaps there's a non-aqueous phase at the site that is highly mobile, or perhaps a dissolved phase plume is starting to spread off-site. So that would be clearly a goal to reduce the mobility of those two phases. Perhaps there's a soil contaminant problem, and the immediate risk is to remove the impacted soil so that nearby children will not play on the soil. Immediate term goals are those that are very real. Perhaps deplete the source mass to allow for natural attenuation to work, reduce the dissolved plume outside of the source zone, decrease the mass, discharge, or flux that would emit from the source, or reduce the mass and volume of the source to some degree. And of course, the long-term site effective will likely be, for everyone involved, regulatory standards. Both these objectives, you have to be real, they have to be effective and efficient. So let's first talk about ways to measure the effectiveness of a cleanup technology. One that would produce a real reduction in contaminant mass, a reduction in contaminant concentration, a reduction in contaminant mobility, or a reduction in contaminant toxicity. With regard to toxicity, that perhaps relates to a compound that perhaps through a transformation reaction would become a less toxic compound. Its friend to effectiveness is efficiency, and that deals with it when, for a particular chosen remedial technology, you would want it to be cleaned up within an appropriate time frame. Perhaps energy requirements are important. Perhaps cost is extremely important, so you then want to be able to quantify the mass of contaminant removed per dollar spent. And in terms of system design, you want to be able to optimize the remedial system to reduce the time frame, minimize energy requirements and cost, and through an engineering process end up with a optimal remedial systems. Now the word over there is actually plural because one would think that you would have a range of possible technologies that would span a site from early on in the site to late in the site profile. For example, at the very start, you may want multi-phase extraction system on site to remove very highly low contamination on the site. And then as the site goes through its history of cleanup, at the other end, there likely is some remnant mass that's present in the site, and perhaps some natural attenuation process may work. With regard to metrics, they are actually the performance data collected at a site to assess the effectiveness and the efficiency of a site. So that requires performance monitoring at the site, where you actually measure specific site characteristics, perhaps groundwater, gas phase, and soil. And of course, that depends on the technology and the site. And those data that are collected are then comprised the performance metrics of the site to get at the objectives of the cleanup effort. Some examples then are bulk soil concentrations, groundwater concentrations, the mobility of the free phase, the mass extracted, or risk. The ones on the right side are not direct data that would impact how clean the site is, but are the associated data as cost, the time frame, the amount of energy consumed, any inputs to the air shed, water consumption, the amount of waste that is created, surface impact, and perhaps an increase in site liability. One example of a remediation metric for a soil vacuum extraction system might be the mass extracted. And in that case, you would be able to sample the effluent, monitoring the off-gas concentration, water to the extracted flow rate. And combined, you would be able to sum the flow rate times the concentration over an appropriate increment of time. And that would then be the amount of mass extracted by the SVE, a real clear metric, mass extracted by a remediation system. That was a very quick overview of some considerations for objectives for site cleanup. The next segment will deal with a collection of options that are available for site cleanup. Bye for now.